Hi, this is Suresh Kumar from Combinational College of Engineering and Technology in Department of Electronics and Communication Engineering. In today's, we are going to discuss about the VLSI design, unit number 2. The title is Design of Combinational Logic Circuits. So in this unit, we are going to discuss about the various concept of combinational logic circuits, such as static CMOS logic and the ratioed CMOS logic, and the third, the most important one, is a dynamic CMOS logic. So these three logic basically we are studied in this unit, and also some other logics also we are studied in this unit, that is a domino CMOS logic, a dual rail domino logic, and the most important, finally, the most important one is a static and dynamic power dissipation. This is a very, very the most important question in this unit. So in today we are going to discuss about the dynamic CMOS. So in previously we have studied the two different types of CMOS logic. The one is called as a static CMOS logic, and the another one is called as a pseudo NMOS logic. This is a third logic. The third logic is a dynamic CMOS logic. So why we are coming from the previous two logic to this logic? The first logic is a static CMOS logic. So in this, suppose if you are choosing this logic means, so we require the 2n number of transistors. That means if you are need, that means you need n number of NMOS transistor and also n number of PMOS transistors. For example, if you designing the two input NAND gate by using the static CMOS logic means we require two number of NMOS transistor as well as two number of PMOS transistors. Totally we require four number of devices. Okay, this is a static CMOS logic, and the second one is a pseudo NMOS logic. So in this logic, when compared to the static CMOS logic, here we are reducing the requirement of transistors. So in the pseudo NMOS logic, we need only n plus 1 number of transistors. N plus 1 means we require n number of NMOS transistor plus additionally only one PMOS transistor. This PMOS transistor should always to be grounded. So this is about the pseudo NMOS logic. And the third logic, which is called as a dynamic CMOS logic. So in the dynamic CMOS logic is also just like a pseudo NMOS logic, but what is a comparison between the dynamic CMOS with pseudo NMOS means in pseudo NMOS logic the PMOS is permanently grounded, but in the dynamic CMOS logic the PMOS which is controlled by the signal pi. Okay. So this is the general diagram for the all the three logic. The first one is a static CMOS logic, and second one is a pseudo NMOS logic. Here the PMOS is permanently grounded, and the third, the one is a dynamic CMOS logic. So dynamic CMOS logic, all the logic operations which is done by only the pull down network, that means NMOS only. Okay, so we are having the n number of pull down network plus additionally only one PMOS which is controlled by the signal pi. And this is a mode of operation for dynamic CMOS. We are having the two number of mode we are using in here. The one is called as a pre-charge mode and another one is a evaluation mode. Here we are going to discuss about the what is a pre-charge mode and what is a evaluation mode. So pre-charge mode means pi is equal to 0. So pi is equal to 0 means for PMOS we are applying the 0, and evaluation mode means pi is equal to 1. That is called as evaluation. See the waveform for the two different modes. So first initially the pi is equal to 0. Pi is equal to 0 means what will happen? the PMOS is turn on. Pi is equal to 0 means the PMOS is turn on. So when the PMOS is turn on, so what will happening in the output for the CMOS inverter? So we can get the logic 1 as a output. And next the pi value will be going to the evaluate mode. So evaluate mode means what will happen? Pi is equal to 1. So pi is equal to 1 means what will happen? The PMOS will be turned off. The PMOS will be turned off means definitely we know definitely the logic 1 is not a output. So we know the output is 0. And again the value of pi value will be coming to the 0. Pi is coming to 0 means what will happen? The PMOS is on. The PMOS is on means we can get the output is logic 1. Here we are having the one drawback. Suppose at a time the both a PMOS and NMOS will be turn on at the same time. What is the condition for that? Suppose we are giving the pi is equal to 0. Pi is equal to 0 means PMOS will be turn on. And same meanwhile time we are giving the value a is equal to 1. So in this diagram, suppose we are giving the pi is equal to 0 at the meanwhile time a is equal to 1 means both the PMOS and the NMOS are turned on simultaneously. So what will happen? This VDD potential it is directly short with ground. So this is one of the major drawback in here. So we need to rectify this drawback. Okay. For rectifying this drawback, we are additionally use the one gate that is called as a footed gates. The footed gates which is lies in the series of pull down network. Series of pull down network, we are using the footed gates. So by using the footed gates, we can avoiding this problem. See, listen here. This is an ordinary one, unfooted logic diagram. See, listen this. So this is a with footed gates. The footed gates are seriously added with pull down network.